TT3 control. Light-off issue. The following video will discuss an old solar starting problem with TT3 controls. This was an issue that came about due to technology advancement. With the introduction of electronic actuators, all turbine manufacturers were faced with a new problem. The fuel actuators could change position so quickly, they could open up fully in milliseconds to try to deliver more fuel when a turbine flames out. With so much fuel in the combustion chamber, it is inevitable what happens next. This is an overview of what the fuel valve logic looked like at that time. There is a single output signal given to the fuel valve, fuel signal. The logic feeding into this output will make the selection. You can't have two control loops in control, so to allow multiple inputs to control one output, you must use some form of a selection process. The minimum error makes that selection. It looks at the difference between the set points of each of the 5 signals trying to control the valve, and their current operating points. This creates an error for each of the 5 signals. The control system passes the signal with the minimum error to the P&I controller block. This block will select the appropriate proportional and integrated gains to be used in the min gate. At the minimum gate, you have 2 additional tunable values that are part of the selection for the minimum gate. The intent of the logic is to use the light off and start ramps to give a smooth light off. Adjustments are needed to allow for differences in build, operating conditions, etc. Once the turbine was lit off, the start ramp would normally take control of the turbine as it accelerated. One of the control changes that solar made was gas DP or liquid DP control, depending on the fuel. For fuel to enter the combustion chamber, it must be at a suitable pressure. Too low and it will not be able to enter, and if it is too high, it may cause difficulties lighting off or have stability issues. As long as the fuel is kept at a specified differential pressure higher than PCD, all will work well. If the turbine flames out, the positive difference between fuel pressure and PCD will be lost. The fuel pressure will stay constant while the PCD will fall off quickly. In this situation, gas DP and liquid DP control takes over and prevents the fuel valve from being opened further. This DP control is not only used while at service speed, it is also present during starting. The electronic PEC and CCC valves were introduced while TT3 was still the control for new equipment sales. This new gas DP and liquid DP control has a tendency to take over control before the turbine even lit off. If a turbine is not lighting off, it would be normal practice, after exhausting any other possibilities, to adjust the gain on the light-off ramp. This will allow the fuel valve to open a little quicker, giving the turbine longer time with more flow to light off, within the time limit set by the ignition timer. But if gas DP or liquid DP takes over control, preventing any additional fuel, any changes you make to the light-off ramp would be futile. This tended to happen more often on CCC than on PEC fuel valves. The fix was to modify the logic to force the control to stay in light-off ramp until it lit off. The logic for Turbotronic 4 does not have this issue. There are probably still units out there that are poor at starting, and this may be the problem. It is difficult to know for sure, unless you record all the logic addresses, to see exactly what is happening in the selector gates. A simple change to the logic is all that is required, but being a safety critical system, it needs to be approved by solar.